Okay, so let's continue with the next one. So this one we are talking about independent event and multiplication rule. So basically just now we already learned about the mutually exclusive, which we say that there's no intersection between the point. So independent event, so when we say that the two events are independent, meaning that the two events can happen without affecting by each other. So meaning that, for example, that I write here is like when you select something, or like when you, okay, like for example inside a box I have like 5 balls. So after I take out like I have 2 different color of balls inside. So after I take out the first one, then after I record down the color, then I put it back, then I do another selection. So like no matter what do I select or which one I get for my first trial is not going to affect my second one. So this is what is that mean by independent. Or the other thing is like performing separate action. So meaning when I roll the 2 dice, so meaning no matter what I get for the first dice is not going to affect my second dice. So this is what is that mean by independent. So normally for this kind of situation, that normally we will try to solve it by using a tree diagram. Okay, so the idea for the formula, or like the method that for us to find the event that is independent, that what is the probability for event A and B occur, is that for probability for A intersect with B, so meaning like for A and B to happen is basically using multiplication. Okay, so we will try to look at these 2 examples, then I will show you what is that mean by the independent event. So we try to do this first. So I think you already learned this in IG also, like how to draw your tree diagram. So we are just going to like do a very simple example, then after that we move on to the question. Okay, so number 1 is sampling with replacement. So this is basically independent. So how do we prove that? So consider a bag with 3 red and 5 blue balls inside the bag. So when a ball is chosen at random, then the color is recorded, the ball is written. Then after that you select the second ball. So how are you going to draw your tree diagram? Is that, so you need to find out first how many type of outcome that you have. So you have 3 red and 5 blue. So that's why you will start to draw it. Okay, so first one you start with, you have a red one. So the outcome is you are going to have 2 outcomes when you select the first ball, is either a red one or the blue one. Okay, so what is the probability for you to get a red one? So it's basically of 3, then in total you have 8, right? So that's why you have a chance of 3 over 8 to get a red ball. At the same time, you have 5 over 8 to get a blue ball. Okay, so this is how you started. So after that, after you get a red ball, then after that you are going to put it back to the bag. Then after that you are going to select the second ball. So because you are going to put it back to the bag itself, so meaning that what is your first outcome doesn't actually affect your second outcome. So even though the first one you are getting a red one, then the second one I also have the chances for me to get a red one or a blue one. Okay, so what is the probability? Is still the same, which is 3 over 8 for red and 5 over 8 for blue, because I'm going to return the red ball inside. So it's the same thing. So even though the first one I get a blue ball, then what happened when I try to do the second one is going to be the same. I have chances for me to get a red one or a blue one, so which is basically 3 over 8 and 5 over 8 also. So what you can realize here is that when we try to write it, right, so like we have chances of like the red ball. So probability for me to get a red one, so it's basically 3 over 8, correct? So probability for me to get a red ball is 3 over 8, and probability for me to get a blue ball is basically 5 over 8. So what you can realize for everything here, if I want to find out the probability that I'm getting a red ball and a red ball, I will use 3 over 8 times 3 over 8, right? So which is basically you realize that for me to get the probability that I get R for the first one, and I also get the red one for the second one, will be equals to 3 over 8 times 3 over 8, which is basically PR times PR. So if I want to find out what is the probability, for me the first ball is a red one and my second ball is a blue one, then you see it's 3/8 times 5/8, which is probability of the red one times probability of the blue one, which is I'll use 3/8 times 5/8. The same thing go for blue red, then I will use the blue one times the red one for the same thing. So meaning that when I want to get this one, then I will use the blue one to times the red one. Then if I want to get this one, then I will use the blue one to times the blue one. So this is what is that mean by independent, meaning that what am I going to do for the second outcome? What I did in the first outcome is not going to affect my next outcome. So normally for this type of question, then we can straight away use the probability that is given, then I times them together, then I will get the probability for A and B to occur. So for the second situation here, right, is actually a dependent one. So what is the difference between this situation and the first situation is that for this situation, right, it's without replacement. So what is the consequences of this? Okay, let's try to do this. So the first outcome is still going to be the same, right? So I have a chance of 3/8 for me to get a red one, and I have the chance of 5/8 for me to get a blue one. But now if because of without replacement, so what happened is when I already pick one that is a red color, how many red color do I still have in my bag? I only left with 2. And how many balls do I have inside the bag? I only left with 7. So that's why when I continue to draw this, which is my second outcome, I'll realize that for the red one, I already picked one out from the 3 already. So how many I left? I only left with 2. And then after that, I have 7. Like the sample space becomes 7 now. So how about the blue one? The blue one, I will still have 5, right? So 5/7. Okay? So it's the same thing for blue one. So if blue is get selected in the first outcome, then what happened? Meaning the red one, I will still have 3. So that's why it's going to be 3/7. And then the other one, the blue one, is going to be from 5. I already picked one and I didn't return it, so I left with 4. So 4/7. So when I do this, you can realize that so actually from the started, right, my PR is actually 3/8. It's the same lah. And then my probability for me to get a blue one is actually 5/8. But when you want to find what is the probability that you get both red, can you actually use 3/8 times 3/8? No, you can't do that, because what happened is what is your first outcome is going to determine what is the probability of your second outcome. If your first outcome is red, then the probability for you to get a red after that is going to be 2/7. But if your first one is a blue one, the probability for you to get a red after that is going to be 3/7. It's no longer 3/8 anymore. So that's why in this case, then we cannot use the formula like PA times PB. Then what you can realize is you have a new probability. So meaning like what happened here, it will become 3/8 for a red one, then the second time it will become 2/7 and you get your probability. So the same thing, if you want to find the first one is the red and the second one is blue, it's going to be 3/8 times 5/7. It's no longer 3/8 times 5/8 from blue, because what you pick at the second one is going to be different. Okay, so the same thing. So here that the blue first one and then red the second one, it will become 5/8 times 3/7. So the same thing, so P for blue and blue, then it will become 5/8 times 4/7. So you can see this is a dependent case. So meaning that you cannot use your original probability, then you times them together and you get the probability that event A and B occur. Because what happened to your second outcome is going to be determined by your first outcome. Okay, so I hope that you can like see this clearly, that you would able to know how to do it. So in the next example, we will try to do it using tree diagram first. So after you get familiar like how to check whether it's independent or not, then after that you can start to like if the question didn't really ask you to draw, you can actually skip it. But I recommend you can try to draw it every time, like if you have extra time, that it will be very helpful for you to check your answer and to see your question in a more proper way. Okay, so let's look at example 1. So a coin is tossed 3 times. Draw a tree diagram to show the possible outcome and the probability. Sorry, tree diagram. Okay, so the toss is the coin is tossed 3 times. So meaning you have 2 probability, right? The head or the tail. So for this one, maybe we write H and T. Okay, so the first one, I will have a probability of getting a head or a tail. So what is the probability? Is 1/2 and 1/2. So the same thing. So is this an independent one? If the first time I get a head, does it affect me for my second time? No. So when after I toss the coin, right, when I do it second time, it's going to be a totally new event also, which will give me 1/2 probability also. So that's why when I continue, HT is going to be 1/2, 1/2 also. The same thing for this one, I have HT, which is 1/2 and 1/2. So if I continue it, then after this, I'll have HT. Same thing here, HT. And same thing here, H and T. And same thing here, H and T. Okay, sorry, I think maybe you can try to draw it here. I know that the space is like a little bit small here. Okay, but I try to, because I feel like I'm using like a lot of like pages and so on. So if you want, maybe you can draw it here, then you have a bigger space. So write down also for every of your probability. Okay, so find the probability that it show head on all the 3 tosses. So it's the same thing. If you realize that this is actually an independent one, then what you can do is you can straight away get to your answer instead of like drawing the tree diagram if the question didn't ask you to draw. Okay, so the show 3 heads at all 3 tosses. Okay, so you have 2 ways that you can write. The first one is, if you don't want to write the intersection, then what you can do is you just write HHH. It's totally fine. So if you don't want to do that, if you want to draw it in a more proper way, then I would say just draw it like intersect. So like the first one you get a head, and the second one you get a head, and the last one you get a head. So what's the difference between the intersect and the union just now? So you still remember the union we are talking about, the first one is head or the second one is head. So meaning I can have either one. But now when we talk about like all 3 tosses must be head, meaning that it is a and. So meaning that I want to find out like all the 3 times that I do my experiment is all head. It's not all, so it's like all head. Okay, so that's why it will be equal to, so what is the probability for everything? The first one for me to get a head is 1/2, or if you want to write it, then it will be, because this is independent, right? So meaning I can always write probability of H times probability of H times probability of H, which will give me 1/2 times 1/2 times 1/2, which is equals to 1/8. Okay, so second one, it shows the same on all 3 tosses. So meaning that you have probability for head, 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 and also probability for toe, toe, toe. Sorry, tail, tail, tail. Okay, so after that, what you try to do, the same thing. So you will use this one times this one, 1/2 times 1/2 times 1/2 is going to be the same for TT also. So you can straight away 2 times 1/8, which gives me 1/4. Okay, the last one, it does not show the same on 2 successive tosses. So meaning that I do not get the same thing when I toss it like 2 times. So basically, what is the outcome that I'll have? If the first time I get a head, then after that I need to get a tail. Then after I get a tail, then I cannot have 2 same on the successive tosses. So meaning that the next one I should get a head also. And then plus the other one that I have is like tail, head, and tail. Okay, so this is going to be the same. So it's basically PH times PT times PH, and then I do the same thing for the other one, which is PT times PH times PT. Okay, so everything will give me the same thing, which is 1 over 2 times 1 over 2 times 1 over 2. So it's going to be 2 times 1 over 8 also, which will give me 1 over 4. Okay, so I hope that you are all right. Okay, so let's move on for the next one. Okay, number 2. Or in this case, if you want to write 1 over 2, so if you don't want to straight away write your answer, you can write 1 over 2 then power 3 also can. Okay, it's the same thing. Okay, so number 2. A student is going to sit for the test in maths and science, so the probability that he will pass in maths and science are 0.7 and 0.5. Find the probability that he passed, failed, and passed what? Okay, so what you can realize in this is that the same thing you need to identify whether it is independent or not. So if a student is going to pass in maths, is this probability going to affect the probability for him like pass in science? So it doesn't affect each other, so that's why this is an independent also. So if this is an independent, then meaning that we can use the what is that called, the formula given here, which is you can straight away times them together. So pass in both subjects, so meaning that what happened here is I want to pass in maths. Okay, so I write the full one maybe. Okay, the probability for me to pass in maths and also pass in science. So since they are independent, so that's why I can use the probability of him pass in maths, and then I times with the probability of him pass in science. Okay, so this is how I get 0.7 times 0.5, which gives me 0.35. Okay, B, fill in both subjects. Okay, so if maths meaning pass, so how do I actually describe for fail in maths? So you still remember about the sample space, right? It's if I'm saying the circle is like the probability for him to pass, so meaning outside the circle is like he failed. So that's why if I am writing like M and S in alphabet, then I can always do M complement and then S complement. So meaning that I do not pass maths, I do not pass science. So how do I find this? So like the P for me to fail in maths, I will times with the probability for me to fail in science. So how do I find this? So the probability for him to pass in maths is 0.7. So that's why to fail is 0.3. Okay, then times with 0.5 also, like 1 minus 0.5, you get 0.5 also, and you get 0.15. Okay, so C, pass in one subject only, then you need to find out the probability, the situation that you will have. Okay, so for example, the first one, it will be like pass in maths and then fail in science. Then the other one, okay, so again, you are talking about different situations, so remember in between is not multiplied, because pass in maths and fail in science is a complete picture. Then you want to add another complete picture, which is another situation, so you use plus. Okay, so fail in maths and pass in science. Okay, then after that you do the same thing, so it's going to be probability of M times probability of S prime, and then plus probability of M fail, and plus times probability of science. Okay, so PM is 0.7 times 0.5 plus 0.3 times 0.5. Okay, which will give you 0.35 plus 0.15, which is 0.50. Okay, yeah, I hope that is like not too hard. Yeah, so for this question, in another way, if you do not want to do this, right, what you can try to do is you can use the answer to minus also can. So pass in one subject mean that I do not want the condition that he passed in both subjects. I do not want the condition that he failed in both subjects. So that's why when you use 1 to minus 0.35 and minus 0.15, you are getting to the same answer also. Okay? Alright, so let's move on for the next one. Okay, so Alice passes through 3 independent set of traffic light when she drives to work. The probability to stop at any particular set of the light is 0.2. Find the probability. Okay, so this is the same thing. So identify first whether this is an independent one or not. So do you think that when she want to pass through the 3 independent set of traffic light, so if he get to stop at the first one, is that going to affect the chances for him getting stopped in the second one? No. So it's like everything that happened doesn't affect on the consequent one. So what happened here is like it's going to be independent also, so that's why we can use multiplication law. Okay, so stop at exactly one set of the light. Okay, so exactly one, meaning that if I'm trying to do S, don't use S because S is sample space. Okay, A is the event that at least stop. Okay, then I can use A for everything. Okay, so I want to find out the probability that he stopped at exactly one set. So meaning he need to pass through all 3 sets, right? So meaning that I can have the first one he stopped, and the second and the third one she didn't stop. So that's why A prime, A prime. Then after that, plus, again, is the second situation. So I use plus, and then A prime. So first one didn't stop, but I stopped at the second one. Okay, then the last one, meaning I have the first one, second one didn't stop, and I stopped at the last one. Okay, so after this, what you can realize is when you are going to multiply them together, right, it's actually going to be the exactly same thing, because you have all the 2, like you are going to have 2 A prime and 1 A. So if you want to like combine them together and do 3 multiply, is totally fine also. But if you want to write everything out, it's okay also. Alright, so I'm just going to do 3 times what is your PA. Probability for you to stop is 0.2. So the probability for you to like go to pass through the light will be 0.8. Okay, so you need 2 times 2 times, so exactly 1 time, and you have 3 situation here. Okay, so equal to, then you times them all together, then you should be able to get the answer of 48 over 125, which will give you the answer of 0.384. Okay, B has to stop at least once. So has to stop at least one, then you need to find out like the probability that he stopped 1 time, stopped 2 times, or stopped 3 times. So if you want to write down everything, then it will be like A stop at least 1. Yeah, so A, or like A prime, A prime, A prime, A, and so on. So meaning like you need to find out the different situation when she stopped for 3 times, stopped for 2 times, and stopped for 1 time. So that will be like very difficult, like I'm not saying like very difficult, but a very long working. So what you can do instead of that is like has to stop at least 1, meaning that what is the situation that I do not want to count here. It's like the situation where she didn't stop at all. So meaning instead of doing like has to stop at least 1, then I'm going to use 1 to minus the probability that she never stopped at all. So when I use the complete one to minus the probability that she never stopped at all, meaning that I'm finding that the probability that she actually stopped at least once. Okay, that will be equals to 1 minus, so same thing, A prime, A prime, A prime, so that's why 0.8 and to power of 3. Okay, then I'll get 61 over 125, which will give me 0.488. Okay, I hope you are alright. Okay, number 4. So Team A competes with Team B in the final of a volleyball competition. The competition will end when a team wins 2 sets. The probability for Team A to win in any set is 2 over 3. Find the probability that the competition ends only after 2 sets. Okay, so for this question, you need to identify yourself, like what is the situation, or what is the situation, or what is the constraint that actually make the competition to ends after 2 sets. So you have the idea for like the competition end when a team wins 2 sets. So if the competition ends after 2 sets, meaning that it's either Team A win for consequent 2 sets or Team B win for 2 sets. So those are the 2 situations that contribute to the competition ends after 2 sets. So find the probability of this, meaning that the probability for the competition to S2 set, basically it will be the probability that A wins for the first one and the second one also A win, or like the second situation is like the first one B win, then the second one is going to be B win also. So for this case, you can see that the probability for team A to win in any set is 2/3. So whenever the first A wins or not in the first set is not going to affect for the second set. It will still be the same, which is 2/3. So that's why A and A to win, it will be like 2/3 times 2/3. Okay, so if you were to write, then this will be probability for A times probability of A lah. So the second one will be probability of B times probability of B. Sorry, times. So if the probability for A to win is 2/3, meaning that the probability for B to win will be 1/3, which is like when the team A lost. Okay, so plus 1/3 times 1/3. Okay, so this one will give you the answer 4/9, and then plus with 1/9, which is 5/9. Alright, okay. So B, the team A is the winner after playing 3 sets. So this is the same thing. You need to imagine what is the situation that actually caused A to be the winner after playing 3 sets. Okay, so you must remember the competition will end after a team wins 2 sets. So it cannot be A, B. So if A and A win already, then that's unnecessary for the competition to continue for the 3rd set. So that's why if the team A is the winner after playing 3 sets, that means A is the winner in the 3rd set. But in the 1st and 2nd, it must be different winner, because if not, then the competition will end straight away after 2 sets. So that's why the probability for team A is a winner after the 3 sets. It will be the A is the winner, then after that A lost, then B win. Then only after that, then the 3rd set, the A win again. Or you have the other condition, which is the first one, B win. The second one, you have your A win. And after that, A win again. So only in this situation, then the competition will continue on for 3 sets and A is the winner. Okay, so probability of A, it will be 2/3, then times 1/3 times 2/3. Okay, then plus probability of B, then it will be 1/3 times 2/3 times 2/3. Okay, which will basically give me 4/27 plus 4/27, which is 8/27. Okay, yeah, I hope it's not too hard to understand. Okay, number 5, events J, K, and L are independent given that probability for J to happen is 0.5, for K to happen is 0.6, and the intersect is 0.24. And you need to find out what is the intersection for J intersect L. Okay, K. Okay, so it's already given that the event J, K, and L are independent, meaning that when you times them together, you should be able to get the intersection point. So that's why when you want to find PJ intersect K and is given the probability of J and K already, then you can straight away PJ times PK. Okay, then you are getting probability of J, it will be 0.5, and the probability of K, then it will be 0.6. Okay, then this is how you get your 0.3. Okay, so after that, when you move on for L, you want to find probability of L. So it's given this already. So meaning that the probability for J to actually happen together with L, it will be equals to the probability of J times probability of L. Okay, then you try to substitute every information that you have. So 0.25 will be 24, will be equals to probability for J, which is 0.5, and times with probability of L. Then with that, you can find your probability of L, which in this case, you should be able to get your answer 0.48. Okay, so B, probability for L and K prime to be happen. So this one is pretty easy also. So it's the same thing, they are independent, so meaning the complement, they are independent to each other also. So probability for L times probability of K prime. Okay, so probability of L is 0.48. Then you need to times with probability of K complement. So if 0.6 is probability for k to happen, so probability for k to not happen will be 0.4. Okay, and you should be able to get the answer 0.192. Alright, okay, so let's move on. Okay, so this is the question that we do for dependence. So we'll talk about this further in the next section, but I'm just going to show you two examples here. Okay, a bag contains 12 counters, 4 white, 3 green, and 5 red. The counters are removed once at a time at random without replacement. So draw a tree diagram and find the probability that the first two counters drawn are all white or the two counters drawn are all different color. Okay, so for this type of situation, right, when you realize it's without replacement, meaning that what you're going to get selected in the first one is going to affect the probability for the next term, then what you need to do is it will be helpful that you try to build a tree diagram, because if not you are going to be like very confused when you want to find the probability later. Okay, so you have three outcome here, then meaning that for your tree diagram you will need to do 3. So like the first one, the second one, and the last one. Okay, so the first one that you are having is like a white. Okay, I'm just write down the symbol maybe. So the white or the green or the red. Okay, then you need to write down the probability also. So in total you have 12, 8, 4, yeah, so 12. So for you to get a white is 4/12. It's totally fine that I do not encourage you to simplify first here, because when you simplify then you cannot see like what is the original number. Then once you get selected for the white one, then when you want to -1, then you feel very confused if you simplify. Like 4/12 you simplify, you get 1/3, but later if 1 is going to pick up, then you will realize that like why 1 - 1 you get like 0, but that's actually a ratio, okay, more than the real situation. Okay, so for the green one, then it will be 3/12, and then for the red one it will be 5/12. Okay, so the same thing, after you get the first one as a white one, then after that what will happen is okay, I'm sorry, let me try to redraw everything here that I can have bigger space. Okay, white, green, red, 4/12, 3/12, and 5/12. Okay, so refer to this. Okay, so now after I get the first one as white, right, then the second one I'm going to have another 3 also. So let me finish drawing that. The same thing I have for the second one. Okay, and for the third one. Okay, so you can try to do, so if the first one you are getting, so let's write down every outcome first. Okay, so if the first one that gets selected is a white one, then how many do you left after that? So you only left with 3 white, correct? And now your sample space, it become 11, because from the 12 you already pick one out. So that's why for the white one it will become 3/11. But for the green one it will still be 3, so 3/11, and then for the red one it's still going to be 5, so 5/11. Okay, so 3/12 for the white one. So this one, what is getting affected is like the green one. Okay, so the green one from 3 green it will become 2 green. So that's why 2/11, and this one is still 3/11 and 5/11. So for this case, the one that getting affected is like the R. So the one red is already got selected. So you have the other one which you left with 4/11, and then 3/11, and then 2/11. Okay, so that's something that you might need to like realize or like be mindful of, is whenever you try to draw a tree diagram, right, everything that you are going to draw, when you draw out the branch, the the total or the probability of your sample space, it must be 1. So you can see 4 over 12 plus this one, I'm getting 1. So when I extend here, right, 3 over 11, 3 over 11 and 5 over 11, I'm also getting 1. So make sure every time when you extend every 3, so the total of your 3, the probability must be 1. Yeah, if not, you are not like looking at the complete picture and you know that something wrong. Okay, so A, the first 2 counter drawn are all white, so meaning that you are getting the first one is white, the second one also white. Then you need to find out. So yeah, please remember this is not independent. This is not independent. So that's why you cannot straight away like 4 over 12 times 4 over 12. You need to look at your tree diagram and write down your answer. So the first one is 12, which is 4 over 12. Then the second one is white one also. Then the second one it becomes 3 over 12, 3 over 11 already. Okay, so this one will give your answer to become 1 over 4. For 4 you get 1, yeah, so 1 over 11. Okay, so the B, the first 2 counters drawn are all different color. So you can have white green, white red, green white, green red, red white, or red green. So you want to do that case is totally fine also. That is like your first choices, which you find out the 6 situation and you plus them all together. But the other way that it will be like much more shorter for you to this is to do is instead of like drawing 2 different to counting the probability that the counters are in different color, then you use the sample space, then you minus the one that is the same color. So meaning that I will use 1 to minus the probability for me to get white white, and I minus the second one, the probability for me to get like green green, and I'll minus the other one, the probability for me to get red red. Okay, so which this will be much more easier. So 1 minus, so the white white, which will give me the one that I already did just now. Okay, so for the green green, then I'll have 3 over 12 and then times with 2 over 11. So for the red red, then I have 5 over 12 and I times with 4 over 4 over 11. Okay, then I'll be get the answer as 1 minus 1 over 11 minus 1 over 22 minus 5 over 33, which will gives me the last answer is 47 over 66. Okay, so this is the probability. Okay, 7. At the gym, 60% of the members are men. 1/3 of the men use the gym at least once a week. 3/4 of the women use the gym at least once a week. So a member is chosen at random. Okay, so when you look at this question, right, you see for the men who use the gym is 1/3. For the women to use the gym is like 3/4. So that's why it's going to make difference like whether the person that you selected is a boy or is a man or a woman, because the probability of them using the gym is different. So that's why this case is going to be like non-independent also, because the probability will get higher if the chances if you actually select a woman than select a man, because the probability for women to use the gym is like 3/4, but for the man is only 1/3. Okay, so the same thing, we try to build the tree diagram first. Okay, so at the gym 60% of the members are men, so that's why we try to do men first and then women. So 60% are men, so meaning 0.6 and 0.4 left is for women. So 1/3 of the men use the gym, so meaning I'm going to, okay, maybe like this is gym, G, and second one is like no gym. Okay, so 1/3 of the men use the gym, so meaning 1/3. The one that without gym is like 2/3. Then I continue, women, I have gym and no gym. So for the women, the gym will be 3/4. And then without doing gym, then it will be 1/4. Okay, so after you find this, then it will be very helpful for you when you want to answer the question. So find the probability that the man who does not use the gym for at least once a week. So you want to find a man without using the gym. So that's why it's going to be, is a man and he didn't use the gym. Okay, so it will be 0.6 times the G prime, so 2/3. Okay, So which will gives you the answer of 0.3/2, so 0.4. Okay, so B, it is a person who use the gym at least once a week. So I don't care about whether it's man or women, but I want the person who use the gym at least once a week. So meaning that I'm looking at this one and this one who do the gym. So that's why I can have the probability of men doing the gym, or I will have the probability of the women doing the gym. Okay, so probability of men doing a gym, then it will be 0.6 times 1/3. Then I'll need to plus another one inside for women, which is 0.4 times doing the gym is 3/4. Then I will be able to get 0.2 plus 0.3, which gives me 0.5, which is like half of the probability. Okay, so I hope that you can understand for this part, and later for the last video we are going to see the last part, which is conditional probability.